Yes, good morning everyone. Just give me a minute. Yeah. Good morning, Sudham. Thank you for joining. Good morning, Sanjana. Okay, so myself, Priya RK, and I'm a top educator in the category of EAMCET on Unacademy platform, and I've been teaching on Unacademy platform from last 4 months, and also I am a educator in the offline mode, and I've been teaching for JEE, NEET, and CET category from last 4 years. And this is about the plus subscription, which you can see on the screen. We have three plans. First plan is about 12 months plan, which is about 12,375. We also have a 6 month plan, that is 10,125, and there is 1 month plan also, which is about 2,250 rupees. Okay, so if you want 10% off on this subscription plan, you can use this code PRKLIVE. Okay, so now the question is why we need to go for the plus subscription, right? So here we get a premium content at very affordable price, and therefore here live courses are also there, and separate doubt clearing sessions are also organized. There will be organization of quiz at very regular intervals, and there will be separate batch for preparation. Test series or DPPs will be provided, that is daily practice papers, and also PYQs will be solved, that is previous year questions. And in the single subscription, under a single subscription, you will be having unlimited access to the content on an academy platform. So if you wish to have a plus subscription, please use this code PRKLIVE, and you will get 10% off on this subscription plans. Okay, yeah. So as we are continuing with this topic, electrochemistry, I'll just start with this. So in the last class, we have studied about the voltaic cell or the galvanic cell, and also different conditions when the EMF will be greater than 1.1 volt, external EMF applied. If it is greater than 1.1 volt, what will be the conditions when the current will flow from anode to cathode, when it will flow from cathode to anode. These things we have seen, right? So Daniel cell equation, as we have discussed, zinc, as you know, it will undergo the oxidation at the anode. So it will get converted from Zn to Zn2 plus. Yeah, Zn to Zn2 plus. And copper, it will undergo reduction. So it will convert from copper 2 plus to copper. So this is a very important equation, also called as Daniel cell equation. Okay. Now here we have two half cells. This is a redox reaction, right? This is a redox reaction, and here we have two half cells. What are the two different half cells? First one is the reduction half cell, another one is the oxidation half cell. Reduction half cell means where the reduction is actually occurring. So first we will see the oxidation half cell, because once the oxidation happens, then only the reduction can take place, because the release of electrons are required for reduction, right? Here in oxidation half cell, Zn is getting converted into Zn2 plus by release of 2 electrons. Now these 2 electrons will be accepted by copper 2 plus. This copper 2 plus is present in the copper sulfate solution, okay, in the particular electrochemical cell. So this copper 2 plus will take those 2 electrons and undergo reduction. So here oxidation state has been changed from 0 to plus 2, and here it is changed from plus 2 to 0, right? Plus 2 to 0. So this is a very important equation, Daniel cell equation, and this is its reduction half cell, and this is its oxidation half cell. And this are called as half cell reactions, or also known as redox couples. These two, they are known as half cell reactions and also known as redox couples. Very good morning, Prathamesh. Good morning, Nandini, Chaitra. Thank you for joining. Okay, fine. So these reactions will occur in the electrolytic cell. Okay, that we have already seen that there is a salt bridge and complete structure of this electrochemical cell we have seen in the class which we had conducted on 12th, right? Fine. Now coming to very important concept, that is standard electrode potential. Now what is standard electrode potential or electrode potential? First we will see what is electrode potential. Okay, what is electrode potential? Now you have seen that whenever we have any electrochemical cell, there is a vessel, and in this we are dipping a particular electrode. So in this particular cell, if I'm dipping zinc as the electrode, then the salt will be zinc sulfate here. The solution will be zinc sulfate solution, right? If I'm dipping copper, then it will be copper sulfate solution, right? So likewise, just one example I'm taking, zinc is being dipped in the zinc sulfate solution. Welcome Prajwal, good morning. So zinc is electrode is dipped in the zinc sulfate solution in the electrochemical cell. Now if you just see, there will be a potential difference between the zinc and the zinc sulfate solution. Okay, there will be a potential difference between the zinc and zinc sulfate solution. Why? Because here zinc is in zero oxidation state in the electrode. It's a pure zinc electrode. Whereas in the zinc sulfate solution, here zinc is existing as Zn2 plus. It is existing as Zn2 plus, right? So definitely there will be potential difference between this electrode and the electrolytic solution, right? And that potential difference between the electrode and the electrolyte or the electrolytic solution is known as electrode potential. It is known as electrode potential. So what is electrode potential? The potential difference that exists between the electrode and the electrolyte is known as electrode potential, right? Okay. Now what is the meaning of standard electrode potential? What is the meaning of standard electrode potential? If the concentration of this Zn sulfate, zinc sulfate, ZnSO4, if the concentration of this ZnSO4 solution is 1 molar or 1 unity, okay, 1 or unity, if the concentration of the zinc sulfate solution is 1 unity, then such an electrode potential difference will be called as standard electrode potential. It will be called as standard electrode potential. That is the electrode potential difference between the electrode and the electrolyte when the concentration of the species involved in the reaction is 1 molar, then we will call it a standard electrode potential. Normally, even if it is not 1 molar, then you can just call it as electrode potential. The potential difference between electrode and the solution is called as electrode potential. But if the concentration of the species involved in the reaction is 1 molar, 1 molarity or unity, then such electrode potential difference between electrode and the solution with 1 molar concentration would be called as standard electrode potential. It would be called as standard electrode potential. I hope that is clear for all of you. Okay, now let us just go back to the previous slide. Fine. So here you can see copper 2 plus is getting reduced to copper, and always you can make sure that reduction occurs at the cathode. Okay, reduction occurs at the cathode. And Zn is getting converted to Zn2 plus, that is oxidation, and always oxidation occurs at the anode. It will always occur at the anode. So these are the two important things that you need to remember. Okay, if you have any doubts, you can ask in the comment section. No problem with that. Good morning, everyone. Thank you, everyone, for joining. Okay. Next, coming to how to calculate this electrode potential difference. Okay, so that we will calculate in terms of a component called as cell potential. Okay, called as cell potential. Cell potential, which is represented as E cell. Cell potential. Potential is represented by E. Okay, this is not energy. This is potential here. Okay, so cell potential. Cell potential, what is the meaning? Cell potential is the potential difference between the two electrodes in a galvanic cell. For example, I'll just draw roughly one cell. So here you had dipped a copper electrode in the copper sulfate solution. zinc electrode in the zinc sulfate solution, and these two were connected, right? And there was also a salt bridge, right? There's a emitter also to measure the flow of current. Now there is a potential difference between this electrode and the electrolytic solution, that we will call it as electrode potential, right? But the potential difference will also be there between this one electrode and this electrode, right? So that electrode potential difference between the two electrodes, it is called as cell potential. The potential difference between the two electrodes, the potential difference between the two electrodes would be called as cell potential. Between the anode and the cathode, whatever electrode potential difference is there, that will be called as cell potential. It would be called as cell potential. Now how to calculate the cell potential? So cell potential is usually represented by E cell, that is equals to E right minus E left. E right minus E left means right side which electrode we have? We have the cathode. So electrode potential of the cathode minus electrode potential of the anode. On the left hand side what we have is the zinc, which is the electrode. So E cell is equals to E right minus E left, or E cathode minus E anode. Or at the cathode what happens? Reduction happens. At anode what happens? Oxidation happens. So right minus left means E reduction minus E oxidation can also be written. So you can write this formula into three different forms. E cell is equals to E right minus E left, or you can also write it as E cathode minus E anode, or E reduction minus E oxidation, right? So these are the three different formulas you can just remember to solve certain problems that we are going to take up. Okay, now let us just consider one example. Like this is a cell reaction. Copper plus 2Ag plus gives copper 2 plus 2Ag. Means here copper is getting converted into copper 2 plus. That means copper is undergoing oxidation, whereas silver is undergoing reduction from plus to 0 oxidation state. So it is undergoing reduction. Half cell reactions, as you know, cathode, wherever reduction takes place, that we can take it as cathode, and wherever oxidation takes place, that we can take it as anode. So cathode means reduction, 2Ag plus, 2 moles of Ag plus are there, therefore 2 electrons will be utilized. So it will get converted into 2Ag. Very good morning, Abhishek. Then anode, this is oxidation. That is, copper is getting converted into copper 2 plus, and there will be release of these 2 electrons. These 2 electrons will be utilized by this Ag plus to undergo reduction, right? Fine. Now how to write this particular cell potential of this particular cell or this particular equation? So which is undergoing reduction? Silver, right? So we know E cell is equals to E right minus E left, right? E right minus E left. So E right means E reduction, right? Reduction is which one? Ag plus to Ag. So what I can write? E Ag plus bar Ag minus E oxidation. Which is undergoing oxidation? Copper is undergoing oxidation. Copper 2 plus bar copper. Okay. So this is how you can write any particular cell potential of a given cell. Okay. Now, how to measure the electrode potential? There should be some apparatus, or there should be some method to measure the electrode potential of a given cell. So this can be done by using a standard hydrogen electrode. A standard hydrogen electrode can be utilized in order to measure the electrode potential. So let me just check if there are any comments or any doubts from your side. Okay, fine. Good morning, Shishel. Yeah, measurement of electrode potential. Okay, the potential of any particular cell cannot be measured. Like half cell cannot be measured. Means if we want to measure the potential of only zinc electrode in a Daniell cell, it is not possible. only half cell we cannot measure. We can measure the difference between two electrodes. Okay, we can measure the difference between two electrodes, but the measurement of potential of a single electrode is not possible. Okay, so what we do is we choose one of the electrode as a standard electrode. Okay, as a standard electrode, like among the zinc and copper, one we will replace with a standard electrode whose potential we know. Then we can calculate the potential difference between one of the electrode and the standard electrode, because standard electrode we know its potential, right? So if you know the potential difference, then the other potential difference of the unknown can be determined, right? So we use here as a standard hydrogen electrode. Standard hydrogen electrode. Now how to represent the standard hydrogen electrode? Platinum bar H2 bar H plus. This is the way we represent any particular electrode. Okay, and is assigned a zero potential. It has a zero potential. Standard hydrogen electrode, it has a zero potential at all the temperatures. Okay, now what is this hydrogen electrode is made up of? It is made up of a platinum electrode coated with platinum black. Okay, there will be a platinum electrode, and at the bottom of that it will be coated with platinum black. What is platinum black? Powdered form of platinum. You know, powdered form of platinum, usually it will give more surface area for the reaction. Now this electrode, it is actually dipped in an acidic solution, and once you dip it in the acidic solution, there will be evolution of hydrogen gas. Okay, and pure hydrogen gas, it is bubbled through it. Then the concentration of both the oxidized and the reduced species, it is maintained at 1. Okay, concentration, as we know, for standard hydrogen electrode, it should be unity or 1, right? So how this looks like? So this is the apparatus where you can see this is the platinum electrode, and at the bottom of it, it is coated with platinum black, that is powdered form of the platinum. Powdered form of the platinum is present. So this is also known as standard hydrogen electrode, SHE, standard hydrogen electrode. So here you can see there are bubbles of hydrogen gas. There are bubbles of hydrogen gas which are bubbled through it and in the solution, and the pressure maintained is 1 bar. The pressure maintained is 1 bar, and the concentration here it is maintained as 1 molar. Now you know the potential of this particular electrode. So if you connect it with some other electrode, then there will be potential difference that you can measure. So for example, if the potential difference you know, that is X value, and potential difference you know, that is the X value, and one more potential you know already, let me take it as Y, then you can measure this potential as A. The potential of this particular electrode can be measured as A, right? So by knowing the potential of one of the electrode, the potential of the other electrode can also be determined. And for that, what we use here is standard hydrogen electrode, whose potential is always 0 at all the temperatures. Okay. Now these are some reduction potentials of different species that are available. For example, here you can see 0, which is written for hydrogen. This is taken as a standard. Okay, just now I told for standard hydrogen electrode, what is the potential? The potential is 0. Okay, and above this hydrogen, whichever species are present, you can just observe all of them, they have positive values of their potential difference or standard potentials, right? Whereas below this hydrogen, if you just observe, all of them, they have negative values of standard reduction potentials. So these negative values imply that they will act as reducing agents. They will act as reducing agents. Whereas these positive values, they imply that they will act as oxidizing agent. They will act as oxidizing agent. Now, how to identify which is a better reducing agent and which is not a better reducing agent? Greater the negativity means more negative value, then it will be a good reducing agent. For example, if you just see here, we can compare nickel and lithium. Nickel has a reduction potential of minus 0.28 volt, whereas lithium has a minus 3.05 volt. Which is more negative? Definitely minus 3.05 volt. This is more negative. Therefore, among nickel and lithium, definitely lithium will act as a greater reducing agent. It will act as a better reducing agent because its standard electrode potential values are more negative. These are less negative, right? Now coming to this positive values. So as I said, if the reduction potential values are positive, then they will act as oxidizing agent. Greater the positive value, stronger is the oxidizing agent. For example, among fluorine and what we can compare here, copper, right? Among fluorine and copper, if you compare, copper has value of plus 0.34 volt, whereas fluorine has a plus 2.87 volt. So this is more positive, and therefore fluorine will act as a better oxidizing agent than copper, right? Okay, so this is about the standard reduction potentials. Fine. Now coming to electromotive force. Electromotive force is nothing but same as that of cell potential. Okay, what is cell potential? The potential difference between the anode and the cathode is known as cell potential, which is also designated by E cell, and also sometimes it is called as EMF, that is electromotive force. Electromotive force or cell potential represented by E cell, or sometimes they can also say EMF of the cell. So how to calculate it? It is the same formula, that is E cell is equals to E reduction minus E reduction minus E oxidation, right? Just a small mistake here. Yeah, E reduction minus E oxidation, or else you can also call it as E cathode minus E anode, or else E right minus E left. Both are same. E naught cell or even EMF of the cell, both are same thing. Okay, cell potential or EMF or electromotive force, it is same. One very important thing is cell potential is an intensive property. So I hope in the first year you have studied about intensive property and extensive property in thermodynamics chapter. So cell potential, it is based on the potential energy per unit of charge, and therefore it is a intensive property. It is a intensive property, right? So one example, let us just see. For Daniell cell, we can calculate the cell potential. So here for oxidation in the cell, this is oxidation, okay, just E naught value is minus 0.76 volt, whereas for reduction it is 0.34 volt. So oxidation means definitely it is related to zinc in Daniell cell, and reduction means definitely it is related to copper, right? So how to calculate this? So again there's a slight mistake here. Yeah. So E reduction cathode value given is 0.34 volt. 0.34 volt for copper. Minus is already there in the formula, and E naught of oxidation or anode. So how much is that value? Minus 0.76. So already minus is there in the formula, and we have this value of E naught oxidation also as minus 0.76 volt. So if you just solve this, it will be 0.34 volt. Minus and minus, it would be plus. So 0.34 volt plus 0.76 volt. So your final answer would be 1.10 volt. So always I think we have done, if E cell external potential applied is greater than 1.1 volt, or E cell if it is less than 1.1 volt. Three condition we have seen yesterday. If external potential applied is 1.1 volt. So I hope how you got to know that it is 1.1 volt, because the cell potential here it is nothing but 1.1 volt, right? So yeah, my next live YouTube session will be on 14th. So if you are interested, you can join at 9 a.m. and the topic would be electrochemistry, and I would be taking Nernst equation in that particular topic and problems based on Nernst equation. So 14th of December 2020 at 9 a.m. and topic would be electrochemistry. So if you have any doubts to ask, you can please comment in the comment section. I would definitely clear your doubts for the same. Hello Vicky, thank you for joining. Please follow me on Unacademy, and the link is provided in the description box of this particular video. So you can please go through the link and please see different classes that are available as taught by me. Okay. Yeah. So if anyone has a doubt, you can ask in the comment section. I'm waiting for your replies. So I'll give you 2 minutes. So if you are interested to opt for the plus subscription, please use this code PRKLIVE so that you get 10% off on the subscription plans. Okay. So waiting for your replies in the comment section. If you have any doubts, then you can ask. And please follow the classes on Unacademy and refer to your friends as well. So Vicky, may I know from which place you are? Okay, fine. So these are the different things that we learned in today's class. That is about the galvanic cell, the two half cells, that is the reduction half cell and the oxidation half cell. And these half cells are also known as redox couples. Okay, because one is having a reduction as the reaction, another one is having oxidation as the reaction. Then we studied about the electrode potential. Electrode potential is the potential difference between the electrode and the electrolyte. And when the concentration of the electrolytic solution is 1 molar, then we would call it as a standard electrode potential. How to calculate this potential difference between two electrodes? By a term called as cell potential. The potential difference between two electrodes, that is the anode and the cathode, it is known as cell potential, or you can also call it as EMF of the cell, that is electromotive force. So it is represented as E cell. Cell potential is equals to E right minus E left, that is E cathode minus E anode, or else E reduction minus E oxidation. Then how to measure the electrode potential difference? The electrode potential difference can be measured by taking one of the electrode as standard electrode whose potential we know, and here we use a standard hydrogen electrode and its potential is 0, right? Its potential is 0. So if I know the potential of one of the electrode and the potential difference between the two electrodes, then the third one can be easily calculated. So by making use of the standard hydrogen electrode, very important from exam point of view, though it is your theory, usually it is asked to explain and draw standard hydrogen electrode, also known as SHE, right? So here the concentration of hydrogen is maintained to be as 1 molar. You can just see these are the hydrogen bubbles which are blown through the solution, and this is the electrode, right? Platinum electrode. As I said, it is coated with the platinum black. Okay. So these are the standard reduction potential values. Negative values indicate they are undergoing reduction, or they can undergo make anything undergo reduction, that is they act as a better reducing agent. Greater the negative value, greater will be its ability to act as a better reducing agent, and greater the positive values, it will act as a better oxidizing agent, right? So EMF or cell potential, it is same. So formula is E cell is equals to E reduction or E cathode, or E right minus E anode or E oxidation or E left. And this EMF or cell potential is a intensive property, right? So this we calculated the electrode potential or the cell potential of Daniel's cell, where oxidation half cell value was minus 0.76 volt and reduction half cell value was 0.34 volt. We know the formula is E of reduction minus E of oxidation. E reduction value was given as 0.34 volt, minus already there in the formula, and value of this E oxidation is also given, that is minus 0.76 volt. Therefore this minus and minus, it would turn up to be positive. So 0.34 plus 0.76 volt is 1.10 volt. So if the cell has a potential of 1.1 volt and the concentration of species is 1 molar, then it would be called as a voltaic cell. This also we had seen in the yesterday's class. So this is about the next live session on YouTube, that will be on 14th, where I will be taking questions on Nernst equation and also derivation of Nernst equation at 9 a.m. on 14 November. So, sorry, no, 14 December. So if you are interested, you can join for the class. Thank you so much, everyone, for joining. Very good morning, Pawan, and have a good day. Thank you.